All right, this video is an attempted explanation of the EGR valve and the air injection system, which are two different systems, but I'm going to try to explain them in one video in separate parts. Let's start with the EGR valve. I'm outside and the sun's shining kind of on my phone, but having a little trouble seeing my phone screen. But here is the EGR valve. This is the valve itself. If you notice right here, you can actually see inside the valve. You can see in the center what's called a pintle. It's what opens and closes the valve. It's the actual moving parts. So what the EGR valve is doing is through this tube right here, it's bringing exhaust gases up to the intake manifold. And the only time it's letting them through into the intake manifold is when the engine computer applies vacuum to this line right here. This vacuum line. When the engine computer sends vacuum through that line, this valve opens and exhaust enters. Trying to get in a position where I can see it. There's the flange where the valve attaches to the intake. This is your intake. So the other end of the pipe on this engine, because it's an 88 F-150 5.0, there's a passageway down here in the lower intake. You can't see it, but there's a passageway that's connected to the exhaust flow. Okay, so the other component to this is right here, this sensor with the electrical wires plugged in, and that is the EVP, the EGR valve position sensor. That's the way the computer senses whether or not this valve has moved. So a little experiment here. I don't have a vacuum pump. For this, you don't really need one. What I've done is I pulled this vacuum line off of its control solenoid. So on this engine, this solenoid is the EGR solenoid. That EGR is the last letter of the R is regulator. It regulates the vacuum to the EGR valve. So the only time the EGR valve is going to get vacuum is when this regulator solenoid sends it. So it has this electrical connector. The engine computer grounds that connection, activates this solenoid, and allows vacuum that's supplied right here to flow out that nipple right there through this line, which I've got disconnected. And the reason I've got it disconnected is there's a simple test you can do to see if your EGR valve is functional, to see if it's frozen in place, corroded in place. Through the window in the side of this valve, you can see the orange at the top and the little bit of silver. And all I'm going to do is I'm going to take this vacuum line and I'm going to draw on it like sucking through a straw or smoking a cigarette, I'm going to apply a vacuum to it. And we're going to watch that center pintle with the shiny spot and the orange spot. We're going to see if it moves. So you can tell when I did that, this is functional as far as moving. So that's one good test. Now, I'm not going to hook this back up right now. Well, yeah, I am too, because I have plans to start the engine. I don't want to start the engine with it flopping all around. So I'll go ahead and hook it back into the solenoid and kind of tuck it back there. I'll rearrange it better later. I don't want it on top of my map sensor right there, but good enough for now. I don't want to make the video any longer than it needs to be. So when does this activate? It only activates on a warm engine when the engine's up to operating temperature, not at full throttle and not at idle. And a little bit of the theory behind that is, in order to improve emissions and fuel economy, and this is straight out of the Haynes manual, it's just what I've read. In order to improve emissions and fuel mileage, the manufacturers leaned the mixture out in the engine, which makes the engine run hotter, makes hotter combustion. So the solution was to introduce exhaust gas into the intake to cool that down. So it only activates on engines that are up to operating temperature, not at idle, not at wide open throttle. So the computer can choose when to activate it. It's at mid throttle, like say you're driving down the interstate doing whatever your interstate speed limit is, just kind of cruising along, it'll activate. Enough about the theory. If this is moving and this is not sensing the movement, then there are tests you can do at these wires, which I'm not going to get into. This is not a testing video per se, because that centerpiece that we saw move, it changes resistance in a sensor right here. That's how the computer says, oh, I commanded it to open, it opened, or it should be closed, it's closed. It's taking a reading, the computer is. So if you're getting codes with the definition of EGR valve not active, I can't quote the codes off the top of my head, and you do the vacuum test I just did and this moves, you want to move to this and test it. The other thing is that this solenoid, this EGR control solenoid, which is the EVR, the EGR Vacuum Regulator, EVR. If you apply vacuum to the bottom port right there, it'll leak down. It's designed to leak down, a slow leak. So if you apply vacuum here, if you have a vacuum pump, and it leaks down, that it's actually supposed to bleed off. All right, so now that's a separate system from the air pump system. The air injection system, sometimes in discussions of emissions controls, those two systems get combined. They're not actually related. I'm going to try to show components of the air injection system. I don't know how successful I'll be, but for one, right there, and I'm trying to watch my phone screen and not block my own light. Right there is the air pump. You can see its pulley right there. Anytime the engine's running, it's pumping air. It pulls air in through this intake right here. So that's its intake. Some trucks have an exhaust that's laying up here in this area. It looks like it's about a quarter of the size of this can right here. It's just a little canister looking device. This model, the exhaust actually, let me try to get positioned here. The exhaust actually comes right out the bottom of this valve. Hopefully you can see that. It's hard to get my headlamp and the camera all in the right place. Right there. So this is the bypass valve. It's the thermactor air bypass valve. The air pump air blows into this valve and comes out through this hose into the rest of the system. But before it goes through this hose to the rest of the system, its default position is to just let the air exhaust through the bottom. Right out through the bottom. So if I started this truck right now in this valve's default position, the air would just escape right out the bottom of this valve. Or on trucks with a separate canister up here on the fender, the air would blow out up here through that canister. And like I said, it's about, I don't know, a quarter of the size of this one. So this is the intake. This is the first component it meets. Let me get my pointer here. My pointer is, by the way, the rod out of the living room blinds, but I knew I was going to need something to point with. All right. So the engine computer controls this vacuum line just like it controls the EGR's vacuum line. So on a cold start, if I started this truck right now, it hasn't been started today, this valve's default position is to exhaust all the air pump air out. After about 90 seconds, vacuum gets applied right here. When that vacuum is applied, the air is allowed to pass through this hose, which hopefully, I'm trying to watch my camera here. I'm going to try to, it's very difficult to see, but it wraps around the back of the engine. It comes up and you can just make out right there the bypass valve. There is the air injection bypass valve. So the air travels through this hose. I can't really tell. I can't really tell if I'm lighting this up properly or not, but hopefully I am. It passes through this hose and pipe. It turns up. And when it turns up, hold on one second. There's something hanging back here. It's an unused connector. When it turns up right here, it 90s into the thermactor air divert valve. So that's TAD, thermactor air divert. This one back here is TAB, thermactor air bypass. All right, so underneath the truck, which it's going to take me a minute to get situated. I have to get a light in here. Give me a second. To get my light set up. Bear with me here. Well, I did this before now for some reason. It's not cooperating. All right, here we go. Here we go. All right. Now, see if I can get my pointer up in here. Let's see. Right here. How am I doing with the camera work? Right here is the tube that comes down from the diverter valve to the catalytic converter. All right. So the air injection air comes back around to the diverter valve. And the diverter valve is very difficult to see from here, but it is right there. If you can see, I don't know if you can see where my pointer is touching. The diverter valve's right there. Let me try to move the light a little bit. This isn't going to be the best produced video. Give me another second to move my light. Trying to get the light where it will shine on these components. All right. All right, well, to not drag out the video, I can't get my light to function correctly. The divert valve, like I said, is right there. So the air comes to the divert valve, and its default position is to get pumped down past this check valve. That's a check valve right there that prevents exhaust gas from going backwards into the system. So the diverter valve default position is to pump air through this tube to the catalytic converter. Its other position is right there. I am touching a crossover pipe, which you can see right there. It travels between the two cylinder heads, and right there you can see the pipe I'm talking about, the tubing. It travels between the cylinder heads and goes into the exhaust port. And right here is another check valve. So the air can either come through this check valve from the diverter valve into this crossover pipe and into the exhaust in the heads, or it can come from the diverter valve into this tube and to the catalytic converter. So on startup, for about 90 seconds, the air pump air is exhausted completely out of this system. After 90 seconds, vacuum is applied to the diverter valve, and the air flows into this crossover pipe, into the exhaust side of the heads. After the engine warms up and the computer is happy with the engine temperature, it sends the air to the catalytic converter. It is, a little confusing when you first look at it, but I think it's because you just don't look at it that often. Actually, it's very difficult to even access or see. But what I'm going to do is I'm going to start the truck, and I'm going to pause the video, start the truck. I'm going to see if we can apply vacuum, going back to the EGR valve, see if we can apply vacuum to the EGR valve and see its movement. And I'm going to see if we can tell or hear the vacuum exhausting out of the bypass valve for the air pump. It's going to depend on the quality of my camera. It's a high-pitched kind of whine sound when the air pump air is bypassing. I'm going to hit pause on this. Hopefully I can hit pause. Well, you know what? I don't have a high-tech phone. I'm just going to start the truck. Okay. So the two things we're going to do after I start the truck is we're going to see if we can hear the high-pitched whine of the air pump bypassing the air out. And then we're going to remove that EGR vacuum line and see if we can influence the EGR valve, and you'll see the influence it has on the engine. Alright, I don't know how good my phone's microphone is, but I can hear a high-pitched whine. I'll try to get where I can actually hear it. But you can hear the whine of that bypass valve, and you can hear the air escape. I'm not going to stick my hands in there, it's too close to the belts. But in person, in real life, you can actually hear it. So that's, if I had the exhaust port for the air injection bypass laying up here, we'd actually be able to feel it blowing out. But you can't. What you can do is you can feel suction right here. You can feel this intake pulling air into the air pump. So now what about the EGR valve and the experiment with applying suction to the EGR vacuum line? So this line is not the one you want to pull off. This will create a vacuum leak if I pull it off. The top line is the one that goes to the EGR valve. So I don't think it creates a vacuum leak, which no, it appears not to, because vacuum's not being allowed through here right now because the engine's cold and it's at idle. But if we carefully, without wrapping this thing up in a serpentine belt or something, come over here and like before, you might be able to see the movement of the valve and listen to the reaction of the engine. And that might have even set an engine code, because that's not supposed to happen under normal circumstances. All right, well, I hope in spite of my kind of shoddy camera work and difficulty seeing these components. I hope that took some of the mystery out. All engines are a little bit different. Like I said, this is an 88 5.0. So, I hope that helps. Thanks for watching.